Hello everyone, welcome to my YouTube channel, that is STEM Smart Academy. In our discussion, we are going to discuss matrices, that is topic 2 of mathematics grade 9 falling under algebra, and we are going to walk through this step by step. One, we need to understand what a matrix is, learners. So we have to start our discussion by defining the term matrix. We have to start our discussion by defining the term matrix so that we understand what we are doing. And when you talk about a matrix, you can say that a matrix is an arrangement, a matrix is an arrangement of items in rows and columns, in rows and columns, in rows and columns. Now, where do we get this application? Just take the example of the sitting arrangement of learners in a class. You will find maybe a class has got maybe 3 columns and maybe 10 rows. So that's an example of an application of a matrix. That's an example of an application of a matrix. Now, because we have said that when you're defining the term a matrix, one, it's an arrangement of rows and columns. That's what you need to know, learners. An arrangement of rows and columns. The items in a matrix are always called elements. So if someone tells you what is an element, this is simply an item in a matrix. So you can say that items in a matrix are called elements, elements. We have to note that, learners, items in a matrix are called elements. You also have to note that matrices are always named using capital letters. Matrices are always named using capital letters, and we normally enclose a matrix inside brackets. We normally enclose a matrix inside the brackets. Let's look at this example. Let us look at this example, learners, to help us understand better what a matrix is. If I have elements A, B, C, and D, and they are wrapped in brackets, then that is an example of a matrix. And if I can say that K is equal to A, B, C, D, this is matrix K, whose elements are A, B, C, and D. Because they are wrapped inside brackets, there you can see the elements have been arranged in rows and columns. The name of the matrix is in capital letters. You can see my K is in capital letter. Now, how do you identify a row and a column in a matrix? How do you identify a row and a column in a matrix? Dear learners, if you have maybe, let's say, for example, you have a matrix, call it M, N, P, Q. Now, to identify rows and columns, this going downward like that is row 1, sorry, column 1, that is column 1. Then N and P are also in another column, maybe we can call this one column 2. So columns are vertical positioning, and when we talk about rows, look at this case, going horizontally like that, M and N, this can be called row 1, P and Q can be set in row 2. So this is a matrix. That is what we call a matrix. Simply an arrangement of items in rows and columns give you what is called a matrix. So if in this case here, If in this case here I'm asked how many rows are here, I can see from this case I have the number of rows. I can say I have 2 rows. The number of columns, dear learners, you can see I have 2 columns, that is column 1 and column 2. Now, having known that, there is something I want to look at, which we tend to call the order of a matrix. Let us look at what we call order of a matrix. Order of a matrix. I want to look at what we call order of a matrix, learners. Order of a matrix. And what do you need to know when you are giving an order of a matrix? When you are giving the order of a matrix, you start by stating the number of rows followed by the number of columns. So when you are stating this, you can say always start always start by stating the number of rows followed by the number of columns, followed by the number of columns, Now learners, this is very important and I'm insisting on that. You must always start by starting with the number of rows, then followed by the number of columns. Don't interchange. So when I want the order of a matrix, I'll start by giving the number of rows times what is called the number of columns, That is how you state the order of a matrix. Let's look at an example to make the point sink home. Let's look at some examples here. Let's look at some examples. Example 1. What is it saying? State the order of the following matrices. State the order of the following matrices. State the order of the following matrices. Let us look at the matrices we have. Part A of the question, we've been given 3, 2, 8, 4, 1, 7, 2, 0. Then we've been asked to state the order of that matrix. Remember, we said that a matrix is an arrangement of items in rows and columns. So under our solution, this is what you need to do. Let's first remember we've said, let's go back here. When you're stating the order of matrix, you start by the number of rows. Looking at our matrix, how many rows do we have? We have 2 rows. That is the first row and the second row. So that will be 2 times. Going back to our statement, the order of a matrix is given by the number of rows and the number of columns. So how many columns do we have? Column 1, 3, 2 is in column 1, 8, 4 is in column 2, 1, 7 is in column 3, then 2, 0 is in column 4, meaning that we have 4 columns. So the order of this matrix is a 2 by 4 matrix. That's how we read it. The order of that matrix is a 2 by 4 matrix. A 2 by 4 matrix. That is a 2 by 4 matrix. Let's look at part example B that is testing something different and we see how to solve that. In example B, you can be given a number maybe 10, 10, 14, 18, 54. Then you are asked to state the order of that matrix. Very simple, learners. Once again, let us see under our solution. I've said you start by giving us the number of rows. How many rows do we have here? 2 rows. 10 and 14 are in row 1, 18 and 54 are in row 2. So that will be 2 by how many columns do we have? 10 and 18 are in column 1, 14 and 54 in column 2. So this is a 2 by 2 matrix. The order of that matrix is a 2 by 2 matrix. I hope I've made that one clear. It's my hope, learners, that I have literally made that one clear. It is my hope that I have made that one clear. Let us now look at something else related to the same, learners. Remember that math is very simple. If you keep revising, things will be very, very easy. I have an example here which I want we have a look at. I have an example here which I want to have a look at. I have an example here which I want to have a look at. In that example, this was question 1. I have a different question. We can call that question number 2. And in our question number 2, we can say grade 9 learners, grade 9 learners were given the matrix below. Were given the matrix below. Let's look at the matrix they were given. We have 3, 4, 5, 9, 7, 9. That is the matrix grade 9 learners were given. Then the question here is, what is the order? What is the order? What is the order of the matrix? What is the order of the matrix? The question is 2 marks. The question is 2 marks. A very, very bright learner will handle it this way. Under your solution, this is what you need to know. When you're giving the order of the matrix, always start with the number of rows. How many rows are here? We have only 2 rows. So that will be 2 times how many columns? We have 3 columns. So 2 by 3 will be your answer. Don't say that the answer should be 6. You just put 2 times 3. We read it as 2 by 3. So the order of this matrix is a 2 by 3 matrix. If you are given this example, this case, there are these scenarios that learners get confused the most. If you've been given, maybe let me call that example 3. What is the order of the following matrices? And now learners, I want to be very keen here. What is the order of the following matrices? Part A, you can be given a matrix, say maybe 7, 3, 2, 4, maybe 1. What is the order of this matrix? It's a matrix because it's arranged in columns and rows and wrapped inside brackets. What is the order of that matrix? Now, under our solution, you have to count how many rows are here. You can see all those elements in that matrix lie in one row. So the number of rows will be 1 times how many columns do we have? 1, 2, 3, 4, 5. So this is a 1 by 5 matrix. That is a 1 by 5 matrix. Let us look at the last example in the order of matrices. Let us look at the last example. That is example B. You can be given 10, 15, 18, like that. Then you are asked, remember the question was to state the order of the matrix. Remember, The question was you had to say the order of this matrix. So under our solution for this is what you need to know is a learner. And our solution, you know that when you are stating the order, how many rows are here? You can see this is row 1, this is row 2, this is row 3. So this will be 3 rows times how many columns do we have here? We only have one column going downwards. So that is a 3 by 1 matrix. That is a 3 by 1 matrix. And that is how you deal with the order of matrices, dear learners. There is nothing complex again there. There is nothing complex there. Allow now I go into something else. That is what is called position of items in a matrix. Position of items in a matrix. Very fast. Let us look at what is called position of items in a matrix. Position of items in a matrix. Position of items in a matrix. Dear learners, when you go to position of items in a matrix, what do you need to know? When you go to position of items in a matrix, what do you need to know? Now, when you want to give a position of items in a matrix, we are still going to follow the order of a matrix. Remember, when you are giving the order of a matrix, you give the number, you take the number of rows times the number of columns. I want now we look at an example to make this point sink home. Let us look at an example so that I will explain this one better with an aid of an example. Let's say identify the position. Identify the position of letters. Identify the position of letters P, comma, S, and T in the matrix below. In the matrix below. Then look at our matrix. Look at our matrix. We've been given matrix A being equal to that is 3, P 3, 4. That's column 1. Column 2 has 4, 1, S 6. Column 3 has T 0, Q 4. We've been told to identify the position of letters PST in that matrix. So learners, this is what we are going to do. Under our solution once again, I want now you be very keen learners. I want to identify the position of matrix P. Sorry, the position of element P in a matrix. What is my matrix? My matrix is called matrix A. You can see A is equal to. So the name of your matrix is matrix A. I'm going now to represent it using a small letter A. That is my matrix. Then when you look at element P, remember row by column. You start by row first, then column. This element P is in row number 2 because this is row 1. This is row 2. So element P is in row 2. So after the letter A here, I'm going to put here 2 to show that I'm looking for an element in matrix A that is in row 2. Then what is the column of element P? It is in column 1. So 2, 1. So when I look at that, if I want to search for it, I come here. In matrix A, row 2, column 1, I'll be finding element P. That's how you interpret that. Similarly, let's here we'll interpret the position of S in this matrix. Looking at the position of S, first you identify which row is it. Element S is in row number 3. So it will be still under matrix A, but row is number 3, so it will be row number 3. Then column number, it is in column number 2. So 3, 2, like that. That is the position of element S. Similarly, I want to get now the position of element T. Element T is found in matrix A, that will be now small letter A. Then what is what is the position for the row number of T? Element T is in row number 1, so that will be 1. Then what is the column position? It is in column number 3. To realize that. So that is how you identify the position of elements in a matrix. You start by giving it row position, then column position, then column position. That is very, very important. That is very, very important. Let's look at the next item in our discussion, learners, which we call compatibility of matrices in addition and subtraction. Compatibility of matrices, that is another substrand. We call it compatibility. Compatibility of matrices. Compatibility of matrices. I want just to call it first compatibility of matrices. Then we are going now to look at the next operation after that. When you talk about compatibility of matrices, compatibility comes from the word compatible. When do you say that two matrices are compatible? Two matrices are said to be compatible, that is, if they are of the same size. I mean the same order. The same order. And what we mean in that case is that for two matrices to be compatible, they must have the same number of rows and the same number of columns, meaning that they should have the same order for them to be compatible. And now when your matrices are compatible, you can perform an operation of addition or subtraction in your matrices. So we can say that two matrices are compatible. Two matrices are compatible if they have the same number of rows and columns. In brackets, what I'm trying to mean is that two matrices are compatible if they have the same order. If they have, remember we explained about order of a matrix. So if they have the same order, then you will say that the matrices are compatible. Maybe let me give an example to explain what we mean. If I have matrix A, let me say this is maybe an example. If I have matrix A whose elements are maybe 2, 6, 8, 9, 3, 7, that is a 2 by 3 matrix, and it happens that I have another matrix B whose elements are maybe 30, 16, 40, 80, maybe 10, 7. When you look at matrix A, the order of matrix A is a 2 by 1 matrix. When you look at matrix B is also a matrix of order 2 by 1 matrix. Because these two matrices, matrix A and matrix B, have the same order, because they have the same order, then we call these two matrices compatible. These two matrices are compatible. And if they are compatible, now you can perform an addition operation or subtraction operation in this matrix. But now let's look at this other different case. This is maybe example 1. If you look at example 2, learners, if you look at example 2, you have matrix K, call it maybe K, whose elements are 7, 9, 6, 2, maybe like that. That is matrix K. Then you have another matrix M here, whose elements are maybe, let's call 3, 6, 5, 9, maybe 10, 40, like that. When you look at the order of matrix K, a matrix K is a 2 by 2 matrix, while matrix M is a 2. Oh, sorry. Let's just have a look at the first case here. These matrices should be 2 by 3 matrix, not a 2 by 1 matrix. The number of columns are 3. The number of columns are 3. Apologies for that. Okay, so but again you can see in my example 1, both matrix A and matrix B have the same order. That is 2 by 3 matrix. So they are compatible. But when you look at this second example, matrix K is a 2 by 2 matrix, meaning 2 rows, 2 columns. Matrix M is a 2 by 3 matrix, meaning 2 rows, 3 columns. Then matrix K and matrix M are not compatible. And because these two matrices are not compatible, we cannot add these matrices, neither can we subtract these matrices. Remember, we only add or subtract matrices if and only if they have the same order, meaning that if they are compatible. I hope I've made that clear. I want to make a point to note here, that is an NB. I want to have an NB here. Now, our NB is a matrix. I want you learners to know this, that a matrix in which the number of rows, the number of rows, a matrix in which the number of rows is equal to the number of columns, is called, this matrix is called a square matrix. We call it, it's called square matrix. It's called a square matrix. As long as it has the same number of rows as columns, then that matrix qualifies to be called a square matrix. I want now to look at the last item of our discussion. That is what is called that is what is called addition and subtraction of matrices. Let's look at addition and subtraction of matrices. Let us look at addition and subtraction. This is very simple now, learners. Subtraction, addition and subtraction of matrices. Addition and subtraction of matrices. Remember, we began our discussion by saying that matrices can be added or subtracted if they are compatible. We can add or subtract matrices if they are compatible. So maybe let's have that point down, that matrices can only be added or subtracted if they are compatible. And remember, when I told you about them being compatible, is that they should have the same order. Let us look at examples. Let's look at examples to make the point sink home. Let's look at examples. And I want to give the first example. I want to give the first example here. So in our example 1, I want we perform this. If I have a matrix 10, 1, 7, maybe 4. I add this matrix to another matrix. That is maybe 2018, 642. What will be your solution? Before you do the operation, the addition operation on these matrices, check if the two matrices are compatible. Yes, they are compatible because they all have an order of a 2 by 2 matrix. When you are adding, you add elements in the same position. For example, what do I mean? You take 10 plus 20, that is going to give you a 30. Then 7 plus 6, that's going to give you 13. 1 plus 18, that will be 19. Then finally you have 4 plus 42, that's going to give you a 46. So your answer, when you combine those two matrices, you are going to get that as your matrix. So when you add or subtract matrices, the resultant answer you get should be of the same order as the individual matrices. Let's look at another example 2 on the same. Let's look at example 2. Let us look at example 2 on the same. In our example 2, I am having, in our example 2, I'm having 5, 1, 4, then 9, negative 1, 7. Then this is being added to another matrix, that is 1, 1, 1. Sorry, 1, 1, 4 here. Then 9, 3, 7. Let us see what happens here. Remember, we've said that when you are adding your matrices, you add elements in the same position. So 5 plus 1, that's a 6. 1 plus 1, that will be a 2. 4 plus 4, that will be an 8. Then 9 plus 9 will give you 18. Negative 1 plus 3, that's going to give you positive 2. Then 7 plus 7 will give you 14. And this will be your answer. As simple as that, learners. You can see how simple mathematics is. You can see how simple these concepts are. And I want to tell you, nothing is difficult here, learners. Nothing, absolutely nothing is difficult. I want to look at the next example. That is example number 3 now. And we learn something out of this example. I'm not saying that it's quite difficult, but it's going to give us another brilliant idea. Example 3, we've been given that matrices A, comma, B and C, matrices A, B and C are such that are such that A is equal to x7, 2y3. That is matrix A. Look at this example keenly, learners. Our matrix B is 3y, negative 7, negative y, 1. Then finally we have and matrix C, whose elements are 4, 0, negative 1, 4. A very, very good question. Then the question says, given that A plus B is equal to C, comma, determine, given that A plus B is equal to C, determine the values of x and y. X and y. A very, very beautiful question, learners. for a discussion here. Now, let's get to the solution of this question. Our solution here, first we need to get A plus B. When you take A plus B, I'm going to take our matrix A learners, that is x7, 2y3. Then I add it to matrix B, whose elements are 3y, -7, -y1. What are you going to get? What are you going to get? So now here, allow I write down here for the because of space. We are going to get, we add elements in this items in the same position. X plus 3y, those are unlike terms, so they will just remain as x. When you add x plus 3y, you are going to get x plus, sorry for that. Okay, we are now fine. X plus 3y will just be x plus 3y, that is going to become one element. Then 7 plus -7, that will become a 0. 2y plus -y, that will become y. 3 plus 1, that will become a 4. So when I add A plus B, this is the matrix I'm getting. And this matrix should now be equal to matrix C, because we are told A plus B is equal to C. So this matrix should be equal to C, which is a 4, 0, -1, 4. Okay, what does it mean? It means because the two matrices are equal, then the elements in each position must be equal. That means when I take the first element in matrix A plus B, that is x plus 3y, this should be equal to the first element of matrix C, which is 4. And this is giving me equation 1. A very beautiful question. The next one, if I take the second the element in the first row but second column of A plus B, that is y, this should be equal to -1 in element C. This is going to give me equation 2. The lower one, 0 is equal to 0 is correct. 4 is equal to 4 is also correct. But what do you learn from these two equations? We can solve them simultaneously, and I want to use substitution methods. When I apply substitution method, I'm going to substitute equation 2 into my equation 1. Wherever there is a y, I'm going to input -1. So this is going to be now x plus, instead of saying 3y, it will be now 3 into -1 being equal to 4. Opening the brackets, this will be x minus 3 being equal to 4. Collection of like terms. -3 crosses to the left hand side, sorry, to the right hand side, it becomes +3. So I'll be remaining with x being equal to 4 plus 3 as 7. Remember already we have y as -1. So your solutions will be x is equal to 7 and y is equal to -1. That is how you respond to such a question. That is how you respond to such a question. If you can allow, I just do one example on subtraction so that to wrap it. But when you're doing subtraction, it's also the same principle, nothing changes. That will be example number 4 of this discussion. Example number 4, you've been given 14, 4, 1, 4, 2, 7, 0, -6, 3. That is one matrix. Then you are subtracting. That is 3, 4, 6, 7, 11, 1, 18, -5, 8. When you are subtracting them, what are we supposed to do? The principle applies. The principle applies. You subtract elements in the same position. Here, let's look at our solution, learners. Let's look at our solution. Our solution says 14 minus 3, that is going to be 11. 4 minus 4 will be a 0. 1 minus 6 will be negative 5. Then 4 minus 7, that's going to be negative 3. 2 minus 11, that's going to be negative 9. 7 minus 1, that's going to be positive 6. Also here, we have 0 minus 18, that's going to be negative 18. Negative 6 minus negative 5. Learners, take note of that. This is negative 6 minus negative 5. Minus negative 5, that becomes positive 5. So that can be read as negative 6 plus 5, giving you a negative 1. Then 3 minus 8, that gives you negative 5. So that is your answer. That is your answer in that case. Assignment question 1, you can also trial 1. You can do a trial on this. You can do a trial on this. I want to do for me, if you've been given 6, 3, 2, this is that is a 3 by 1 matrix. Then you've been told subtract negative 1, 4, 0. What are you going to get as your answer? Drop your answers in the chat section or in the comment section for confirmation. Thank you for this session. See you next time. Goodbye for now.